Okay, so today we're going to kind of bring all of our information together and start to graph these functions. So we're going to be focusing on curve sketching today. All right, let me make this a little smaller. Beautiful. Okay, so here's a basic list, and you can read through this. I'm not going to bore you by reading this. Uh, but these are the processes that you should go through. And I also have the summary sheet, and we always like having comics, right? So we're going to try a few examples. I'm not going to do every single problem. We'll take some time to do a few of each and just practice over the next couple of days. All right, so the first one that I wanted to do, I think that example 3 is a pretty good one. All right, so you have your summary sheet. Let me get mine out here. So we're going to be looking for critical values, increasing, decreasing, all of that. All right, if we check out the domain of this, the domain's going to be all real numbers. So that's not a big deal. All right, one thing that you want to check is maybe some intercepts. This one's easy because it's 0. Another thing you might want to check is if it's even, odd, or neither. So if we plug in a negative m, we actually get the opposite of what we started with. And if you remember that, that means it's an odd function. All right, so that's going to help us graph it, because if we can get like this piece over here, then we'll be able to pull together the whole function, because then we just have to rotate it around. All right, let's get back to that. Beautiful. Okay. X-intercepts. So what would make the function 0? We have 0. The inside part, -2 or 2 would make that 0. So we're pulling together a lot of information. Another thing you should analyze is end behavior. What's happening at the end of the function? So if we let, oh, I should put an m there. M approaches infinity. Our numbers are just going to get bigger. And as we approach negative infinity, our values are just going to get smaller. All right. So now we can start to analyze to find the relative extreme, and we'll analyze the derivative. So we have g prime of m. Come on. All right, back to this. G prime of m is, so we have the first times the derivative of the second. Don't forget to multiply, that's a 2 there. Don't forget to multiply by the derivative of the inside, plus the second times the derivative of the first, which will just give us m squared minus 4 to the 1/3. All right, our favorite thing, factoring out least powers. And what do we have left? Hopefully I do this right. 2/3 m squared plus, and I believe this would just be m squared minus 4. All right, I'm writing that together. Let's see, 2/3 m squared plus 1, or 3/3 m squared, gives us 5/3 m squared minus 4, all over m squared minus 4 to the 2/3 power. All right, I can multiply both parts by 3, just because I don't feel like dealing with fractions right now. And if I feel like writing this, all right, it'll be m squared minus 4, quantity squared, and then cube root of all that. All right, so now we can analyze this. Where would that be? 0. Okay, solving the top. We're going to get 5m squared equals 12. So m squared will equal 12/5, and m will equal plus or minus the square root of that. And if you want to think about it, like where would that be? That would be plus or minus the square root of 2.4. All right, so that's going to be just over 1. So now if we make a little chart here, m, g prime of m. All right, and then critical values here. Square root of 12/5. And we also have 2. All right, so one thing that I'm going to do, since it's an odd function, okay, I'm going to just start at 0, and I know that it's going to be the same on the other side because it's odd symmetry. So I'm going to just rotate these ideas around. So if I plug in numbers, say like 1, something close to 2, 1.9, and then maybe 3, check out the signs. I'm going to get negative, positive, positive. All right, and then I'll be able to rotate it around. So it says sketch the graph. That's what I'm trying to do here. All right, so if we look at this, I know that I'm going through 0, 0. I also know that I have a relative minimum right here at the square root of 2.4. So maybe somewhere down here. Okay, and I have x-intercepts at 2 and negative 2. So I know my function's decreasing. I don't know if it's going like this, okay, or if it's just going like this, but I have a relative min, so I can probably assume this. I could also analyze the second derivative, and then it's increasing. So again, I don't know if it's increasing concave down or if it's increasing concave up. All right, so I could analyze it, but for right now, I'm not going to worry about it. So it looks something like this. And since it's an odd function, I'm just kind of going to mock that side. All right, and it'll look something like this. So this is good enough for right now. I'm just trying to show you how to pull all of this together. Now to get the coordinates of the relative extrema. All right, let's see. Let me get my highlighted relative extrema. So we had a minimum, right, here, and we're going to have a maximum. All right, and we'll have a max at, maybe I should just do it this way. Sorry about this. All right, so we have a minimum here, we have a maximum here. We're going to have a point of inflection here. And so I don't know on this side because I didn't go ahead and analyze it. So it's not a big deal for right now. I just want you to practice because you guys need to practice seeing how the function's related. But maybe we do have an inflection point here and here. We would have to analyze that. And this is where I know we're doing this without a calculator. But this is the point where you might want to use a calculator to find the actual y value here and here. Okay. So this is good enough for what we're doing. I know I'm not really worried about the instructions. I want to see if you could connect the ideas between the function and the derivative. All right, so another one I thought would be pretty good would be example 5. All right, so I'm going to change my color up here. Why not? So on this one, it's not going to have any symmetry. Okay, the domain is all real numbers. We can look at the derivative. Why not? It's not too bad. So first times the derivative of the second plus the second times the derivative of the first. If I find out any critical values, okay, I could factor out e to the x, and I get x plus 1 left over. This is never going to equal 0, and it's always defined. So we're going to have a critical value at x equals negative 1. Plug that into our chart. Negative 2. Okay, so we'll see this is negative, this is positive. So then we're going to have a relative min at x equals negative 1. All right, why not analyze the second derivative? It's not too hard. So I'm going to use that first version. All right, first times the derivative of the second plus the second times the derivative of the first. Okay, then times the derivative of e to the x. So this time I get x e to the x plus 2 e to the x. I can factor this one. Okay, I get e to the x times x plus 2. And you'll see that 0 at x equals negative 2. Making a quick little sign chart. You'll see if we put in negative 1, we'd get a positive value. Negative 3, we'd get a negative value. All right, so that should be enough to pull together a graph, and we should be able to find the range. All right, so we have a relative min at negative 1. It wouldn't hurt to get a point, right? F of 0, 0, that's pretty easy. All right. At -1, we have a relative min. And so we're going from decreasing concave down to a relative min. And see, we start to get concave up at -2. And crossing through 0, and now it's increasing and concave up for the rest of the graph. All right, so that's a pretty good estimation. And if we're going to find the range, well, the lowest value happened to be right there. All right, so if we plug in -1, because remember that was our relative minimum, if we plug that in, we'll get negative e to the negative x, or -1 over, oh, sorry, that's not x, -1. All right, or -1 over e. So the range is -1 over e all the way until infinity. All right, and so I'll do one more problem. I think, let's go with number 9, because that's a good practice. All right, number 9. So here, I know how to factor the top. I don't know if you do, but you should probably start to learn how to do that. Okay, it's the sum of two perfect cubes, so it can be factored. And the bottom can be factored. So I'm going to start on the left-hand side, kind of getting an idea of what's going on here. So I know that I can't have 2 or -2 in my domain. All right, so if I could cross that out, I know we have a hole at 2, or -2, sorry. And now if I plug -2 into this part, that'll give me the value where it is, and it would be -3. I know I have a vertical asymptote at x equals 2, all right, because that's in the denominator and it doesn't cancel out. End behavior, I could analyze that. As I take the limit as x approaches infinity, it's just going to constantly get bigger. And negative infinity, it'll constantly get smaller. Now it says here, analyze the end behavior by using the division algorithm. Whenever you have a degree 1 higher in the numerator, it's going to have a slant asymptote. And you could get that by dividing. So we could do either long division or synthetic division if we use this form. You could have done it from the beginning. In this case, you'd have to use long division. If you want to do that to practice, no problem. But for the sake of time, I'm going to stick to synthetic. All right, so I'm dividing this numerator by the denominator. So I get 1, -2, and 4. Okay, multiply and add. So this means that if I divide those two, I'm going to end up getting the quotient of x plus 4 over x minus 2. All right, this part, guess that's a bad color. Oh well. Let's pick a different one. All right, this part tells us the slant asymptote. All right, so we have a slant asymptote, y equals x. So we could start to pull together some ideas of this graph. We have a vertical asymptote. We have a slant asymptote. All right, and now we can just we could find some points, right? Y-intercept, that's an easy one. Plug in 0, and you get 4 over -2. Okay, 0, -2. We could take the derivative. Sure, why not? Let's see that. F prime of x. I'm going to use this function, because why go ahead and make my numbers larger, all right? So, ho d high minus high d ho all over ho ho. Okay, multiplying that out. I'm going to multiply and simplify in one step. If you need help doing that, just let me know. You should end up with x squared minus 4x over x minus 2 quantity squared. And if I wanted to have that in factored form, okay, it would look like this. All right, and then if we take a little take a minute to pull together our sign chart. So 0, 2, and 4. All right, plugging those values in, or different values in between them, you get these sign changes. All right, and the reason why I put 2 in is because it makes the derivative 0, but it was also not part of our domain. All right, and -2, technically, I guess I should put that in, but because it was an undefined value. But I know that there's just a hole there, so I can take care of that. All right, so this means our functions, we have a relative max here, okay, relative. We don't know if it's an absolute. And we have a relative min at 4. All right, so relative max is at 0, and we already found that point, 0, -2. So my graph's going to look something like this. And remember, there's a hole there. You just can't see it. And then we have a relative minimum at 4. So I don't need to go ahead and find the second derivative because I can tell my concavity just by my picture. All right, and so, and again, this might be stretched out just a little bit more. And we have a hole right there. All right, so there's a whole combination of all the things that we've been doing over the past couple of days. For tonight, just try a problem, or you could try it in the notes, or you could try it in the worksheet, and then come in with some questions tomorrow.